Okay, so our last lesson, right, was on measures of center, all right, taking data and kind of finding a middle ground to represent like all the data. Well, now what we're going to do is taking a look at all of the numbers, the statistics as a whole. They want to know something called the measures of variability. Obviously, variability comes from vary, right? How does it vary? All right, so, and this is you'll notice that these are very tiny. All right, so when I copied and pasted, it came up. So you're going to want to listen, and please feel free to raise your hand and ask me if you can't see a word and you missed it whenever I told it to you. So here we go. So the very first sentence is measures of variability. Everyone?
Measures of variability.
So this is used to describe the distribution of statistical data. Used to describe the distribution of statistical data. On many of these, I don't have synonyms or little easy answers, so we'll save us a little bit of time, but most of the definitions are kind of precise on what they actually are. All right, so some of the things that we're going to be looking at when we talk about measures of variability. Here we go. The first one you guys may have heard of before. It used to be an elementary school standard. It used to go with mean, median, and mode, and that is range. Everyone?
Range.
All right, range, I don't know, in elementary school, a lot of times you learn what range is along with those other three, but they're actually completely different things, right? Mean, median, and mode are kind of similar, but range is a measure of variability. So here's what the range is. This is a measure of variation that is the difference between the least and the greatest values in a set of data. Okay, so the difference between the least and the greatest values in the set of data. Okay, now this next part, range is kind of a more common thing to talk about, and we'll be doing it on our homework, but the next part probably is going to be something new for you guys. So I'm going to just write the definitions down, and then what I'll do is during our problems, I'll show you what they look like. They'll make a little more sense. So here we go. The next word is quartiles. Everyone?
Quartiles.
All right. And it pretty much has a very similar meaning in a lot of ways anyway to what it kind of looks like, and that is quarter. All right. But here's what a quartile is. This is the values that divide a set of data into 4 equal parts. The values that divide a set of data into 4 equal parts. Okay, so here are two pieces or two types of quartiles. All right, here's one. The first quartile, or also known as the lower quartile. I believe, though, the book in this lesson calls it the first quartile. So first quartile, everyone?
First quartile.
Okay, it says for a data set with the median, and they call it M, the first quartile is the median of the data values less than M. And that sounds a lot kind of confusing, but like I said, it's better if we do a problem. You'll see it's much easier than what it sounds. So it's for a data set, bunch of numbers. You have a median. It's actually the first quartile. It says the first quartile is the median of the lower half, basically, is what it is. All right? And then you have the third quartile. Everyone?
Third quartile.
Okay, this is sometimes known as the upper quartile. And this one is for a data set with the median M. It says the third quartile is the median of the data values greater than M. Right? So if you have your median and you have the upper part after the median, it's the median of that section. Okay? And then we have something called the interquartile range. Everyone?
Interquartile range.
All right, so this is the range of the middle half of a set of data. Okay? This is a little more accurate right here. It says it's the difference between the first quartile and the third quartile. So you have your overall range of all the data, and then you'll have your interquartile, what's called your interquartile range, which is the range between your first and your third quartile. Basically, it's your middle section of data. It's your meat of your data. All right? So if you have one of those extremes, it's like it cuts it right off of there. Okay? So that's what an interquartile range is. And we'll take a look at those. Now, remember, I just used that word, those extremes, in our last lesson. And maybe some of you guys know this, but those extremes have names. All right? And a name to one of those extremes is called an outlier. Everyone?
Outlier.
All right? So, there is actually, some of you guys were looking and go, okay, well, what exactly, in the last lesson, what is the extreme and how do we know? It's kind of close, but it's kind of far, and where do you draw the line? Well, they actually give you a mathematical way to find out if something's an outlier or not. So, they say this is data that are more than 1.5 times the interquartile range, beyond the quartiles. So if your interquartile range, you'll know what that interquartile range is. You multiply that thing by 1.5, and if it is bigger than that on the right side of the third quartile or on the left side of the first quartile, then you know it's called an outlier. And that still you may have no idea what I'm talking about. We're going to look at it in just a bit. Okay. All right. So, here's what I'd like you guys to do. Let's go ahead, let's grab our book and flip over to page 444. Okay. Now, what we're going to do is if I look at these problems, right, I gave you some problems for homework, and they all kind of are a little different, but I want to get to the main part of what you need to learn as an advanced Math 7 student, okay, when it comes to our standards. And so when it comes to those type of problems, there's not very many of them. I want to do one, I want you guys to do one in class, and then I want you to have one or two others that are basic problems in your homework. So what I had to do is I had to improvise, and so problem number 3, we are actually not going to follow the exact directions for problem number 3. We're just going to use the data for problem number 3. So we're kind of making up my own problem. Okay, but it's going to fit the problem I'm going to give you guys to try out in just a bit. Okay, so if we take a look, the directions at number 3, actually it fits. It says the number of calories in a serving of certain fruits and vegetables is shown in the table below. Okay, so you see they have a long list of, they have the statistics, the numbers, the data of the fruit, right? All those different fruits, and then they have all of the calories on a number of different vegetables. Okay, in that problem. Okay, and as a matter of fact, I can put the book right here. Okay, what you guys see in front of you. So here's what I want to do. what I want to do is I really don't want to go into detail about A and B on this. Okay, and as a matter of fact, right, this isn't even part of your homework anyway, so we don't have to follow these. What I want to do is I want to use this data up here, and I actually want to follow this. Why? Because your homework, those are the directions of your homework with other data. Okay, so it says find the measures of variability and any outliers for each set of data. All right, so here's what we're going to do, okay? We are going to, let me turn the paper this way. All right, step one is, it's very similar to our last set of problems in our last lesson. I'm going to order it least to greatest. Now, the reason why I'm putting this, you say, well, Mr. Wilkins, it's already like that. Well, yeah, but not all your problems will be, all right? So I'm going to list them least to greatest. Now, what I want to do is and I could do it vertically, okay? But here's the thing. We are not going to find, in this lesson, we're not going to find the mean. As a matter of fact, we're not going to find the mode. So there's really no reason to list it vertically like we did in our last lesson. We're going to list it horizontally, all right, in this lesson. So in this case, we're just going to, and here's what I'm going to do. I'm not even going to worry about vegetables in this part of the lesson. I'm going to just talk about the fruit. So I'm going to say 50, 50, 50, 50, 60, 60, 60, and then 80. And learned my lesson last time, all right? I need to make sure I count. 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, here's what we're going to do, okay? We are going to go over our vocabulary right now in step 2. We're going to take a look at our data. We're going to organize it in quartiles, in range, and interquartile range. We're going to be able to sort it in a way where we can break it down and actually answer all the things that they want us to answer here. So here's what this means. The very first thing I'm going to do is I'm going to find the median. Okay? We'll take a look. The problem is if there was a median, right, it'd be a middle one. But I'm actually going to make up my own median. Right? Well, hopefully this is middle math for you guys. What's the mean, right? Because these are your two numbers, 50 plus 60 divided by 2. What would it be? 55. It'd be 55, right? It'd be right in the middle of the two. Okay? This is our median. Now, sometimes the median will be already there. I'm going to go ahead and circle it. I want to make sure this doesn't look like, that kind of looks like step 5 or something, so make sure I put the number 55 there. Okay? Now here's what I'm going to do. If you remember right, they didn't have median as a vocab word, but it's a big part of what we're dealing with today. Okay? And they didn't have it as a vocab word because that's kind of part of our last lesson as well as your elementary school days. So what I'm going to do is I'm going to take a look at this bottom section. Now, here's why I'm doing this. Because it says a first quartile, it says for a data set with median M, which is the median we just found out, the first quartile is the median of the data values less than M. They're talking about this part. So here's what I'm going to do. Oops. I'm going to call it, sorry. Actually, no, they do call it. They don't call it lower quartile in this book. They call it first quartile. Again, it's the same thing, but I want to make sure I stay consistent with what they're saying. I need to find the first quartile. So I'm not even worried about this part. I'm only worried about the value smaller than our actual median. And it says I'm finding the median of this set of data? Well, again, there's even numbers here, right? So you take the two middles, which, hello, right? They're both 50. So our first quartile is, you can average them out if you'd love to. 50 plus 50 is 100 divided by 2 is 50, right? There's your first quartile. It's the median of the lower half of your data. What they'll sometimes do is this is how they'll label the first quartile. Q with a subscript 1. First quartile. Now, guess what? We are going to find the median of the upper half. That's going to be called our third quartile. So, well, there is no median. So again, we have to average out the two middle numbers. And of course, yes, it's 60. This is called the third quartile. And they'll say Q subscript 3. Guys, what's the second quartile? What's the second quartile? Just kind of look at it. What do you think? 55, right? It's our median. They don't give it the name second quartile because it already has a name, but that's basically what it is. So if you take a look, it's kind of breaking your data into quarters, into fourths. First quartile, your second quartile, your median, and then your third quartile. Okay? Now, once we have, and that was all step 2, identify every single part of it. Now, hopefully the rest is going to be pretty simple. Not all of it, but some of it. All right? So here we go. Step 3. Okay, here's what they want you. It's not very specific, right? It doesn't tell you. It just says find the measures of variability. So here's what they want you to find, okay? They want you to find the range. Okay? Now don't overthink it. The range is the distance between, or the difference between, the lowest data and the largest data. So listen, for note purposes, I'm hoping you guys can all do that in your head, but for note purposes, just write 80 minus 50, like in parentheses, right? The range of this data is 30. It's the difference between the largest and the smallest. It's 30. 80 minus, and it's gotten by subtracting the largest and smallest, right? Okay? I mean, we'll call this step 4. It's not really steps, it's just reminders of what to put down. They want us to list the median. So because we did all the work up here, right? I mean, it seemed like it took forever, but you should be able to now list a bunch of these. So the median was 55. Step 5. They want you to give the first quartile. I'll put Q subscript 1 there. The first quartile was 50. Step 6. The third quartile. Well, that's 60. I kind of consider just making all of this step 3, but it's all right. So here's what they abbreviated it as in the book, IR, but IR is Interquartile Range. So maybe for our notes, we go over to the side and write that where you don't forget. Interquartile Range. Interquartile range. It says it's the range of the middle half of the set of data, the middle half, but more specifically, it's the difference between the first quartile and the third quartile. So it's how far is it between this two? Remember I said it's the main chunk of data. It's in the middle. So the range, interquartile range, and for note purposes, write down 60 minus 50, right? our interquartile range is 10. So the main part of our data is within 10 of each other. In this case, 10 calories, right? Okay, here we go. Step 8. Put a question mark by step 8 because some of them have them and some of them don't. Do we have an outlier? Okay, so listen carefully. Let's go back to the outlier definition. An outlier is data that has more than 1.5 times the interquartile range. So what do you think we have to do first? 10, that's the interquartile range, right? Times 1.5. So what does that equal to? 15. Now listen, that's not our outlier, right? I can even put that in parentheses. This is just on its way to our outlier. You have to find out what 1.5 times is before you even find out if that's the case. Then look, data that are more than 1.5 times the quartile range beyond the quartiles, meaning the first and third quartile. So what's our third quartile? 60. Do we have something beyond 15 bigger? 50, yes. So therefore, 80 is an outlier. So you go, always test both sides though, right? Well, come on, let's face it, right? By look at this, we know there's no outlier here, but if there was, you would say, okay, an outlier, of course, would be what? 35 and below, right? 15 the other way, going lower, but there is none on that end. It's just 80. And like I said, some of them won't have outliers. Some of them will. Okay? So those extremes. All right, questions? Gotta have you guys try one. This is the only type of problem that we have on this lesson because everything else kind of falls underneath all of these skills here. Okay? I'll leave it all up there. I'll leave this up there just like that. The problem I want you guys to work on is on page 444. I want you to work on problem number 4. I'll leave all the notes up here for this. Go ahead and get going on problem number 4. Go. Okay, how many of you need more time? Okay, I'll give you guys another minute. Checking in. How many of you still need more time? Okay. All right, I tell you what, about 15, 20 more seconds, and then I'll have you guys share. It's a lot of stuff to share, so I'll give you guys about a minute when we share too. Okay. Go ahead, turn to your neighbor and share all of your data. Go. Okay, so hopefully you realize that while doing this is that that when you have an odd amount of data, it actually is a little easier, right? Yeah. So here we go. We have Monday to 7 days a week, right? Computer game sales on the day, the number of computers that are sold. So very first thing you need to do is always label it or number it, least to greatest. So if I do this, 80, and then 89, and then 90, 92, 100, 104, and 150. All right, so here we go. Look in there. There's odd amount, 7. That middle number is right here. It's 92. That means that that's our median. This lower half is our first quartile, and this is our third quartile. Okay? So, if I'm looking at my notes over here, range. So, our range is 150 minus 80. Well, 15 minus 8, right, is 7. So our range is 70. Okay. Our median. Well, it's already labeled here. It's 92. And then that leads us to our first quartile, 89. Our third quartile, 104. Our interquartile range, remember, is just the difference between these two. Bless you. All right, again, right, I mean, that's pretty easy. But you can use a calculator. 104 minus 89, 15. Okay? And then, last but not least, outlier. So if I take a look, is there an outlier? And I take a look, and of course we need to take our interquartile range, multiply it by 1.5. So 15 times 1.5 equals 22.5. So for there to be an outlier, it has to be 22.5 beyond these two numbers. So 104 plus 22.5 equals 126.5. Well, 150 is definitely an outlier. I need to try both sides though. All right. So there's my lower quartile, 22.5. Well, let's face it, 89 minus 9 is 80. This we have to subtract 2250. This isn't an outlier. So there's our outlier. All right. Questions, guys? All right. Measures of variability.